Okay, pre-calc, we're back to do the applications of these vectors and the resultant vectors and things, part 2. So now we're on example number 10, and we're going to talk about resultant velocity now. We're going to do it just the same. Instead of force, our magnitude is going to be velocity. So again, the thing that's going to be kind of most important is drawing your picture. Okay, an airplane is traveling at a speed of 550 miles per hour at a bearing of 325 degrees. Once the airplane reaches a certain point, it encounters a wind velocity of 60 miles per hour in the direction of north 75 west. All right, so let's see what we're going to do. I'm going to draw, this is number 10. I'm going to draw the vertical and horizontal as dotted lines. Okay, and then we'll put our vector and where airplane is in there. So the first thing is, it says the airplane's traveling at a speed of 550 miles per hour at a bearing of 325. So since it didn't give us any north, south, west, all of that, we know that's a true bearing. So that means we go from here, the north south, to the airplane at 325. So we start here and we go all the way around here. So there is that right there is 325 degrees. So if we, and that is at 500 miles per hour. Okay, then it encounters a wind velocity of 60 miles per hour in the direction of north 75 west. So we've got to draw that in there. Here's north, here's west. So we have to decide, is it between the y-axis and the airplane, or is it between the x-axis and the airplane? So this little angle here is 360 minus 325 is 35 degrees. So I'm going to write that in here. This is 35 degrees. I don't know if we'll need that. And then our wind is 75 degrees, so it must be over here. And this angle, the green, is, whoops, I wanted that green, is 75 from there to there. From the y-axis to here is 75 degrees, and it is at 60 miles per hour. So let's see what these vectors are. Let's start with the airplane. Okay, the airplane's velocity is 500, and we need to find its angle, and its angle is going to be from here to here. That's how we always measure the angles for these. So that's going to be 90 plus 35. 90 plus 35, and that's going to give us 125. Okay. And the wind, V2, is 60, and that angle is going to be from here to here, which is going to be 90 plus 75. And 90 plus 75 is 165. So when we put them together, we get negative 344.74 and 425.11. And to find the magnitude, again, I'm not going to write out the formula. You know how to do that. Once you put that in your calculator, you should get 547.32 miles per hour. Because now we're talking about velocity. In the last video, we were talking about force, so it was in pounds, but now we're talking about velocity. And then to find, it asks us for a direction. So we're going to find tangent theta equals 425.11 over negative 344.74. What quadrant is this in? This is in quadrant 2. So we're going to have to find our angle from the calculator. 425.11 divided by negative 344.74. And you get negative 50.96, but we have to add 180 to that. And so we get 129.04. But it's asking us for a true bearing. So let's see what it's really asking us for. This 129 goes from here to here. Oops, it's in quadrant 2, someplace over here. So this angle right here is 129. That's 0.04. That's what we just found. But we want to find the true bearing, which goes from here to there. So how are we going to find that? There's some different things that you could do. I would probably, let's see, I would find this little angle right here. So I would take 180 minus 129, and I would get 50 point. So this angle right here is 50.96. And then I would add 70 to that, 50.96, and I did 320. So there's a lot of ways you can do that because you know all of those 90s and 180s and all of that. But our true bearing, this right here is a true bearing because it goes from here to there. So that's, so you can look to see how it wants you to give the angle. All right, let's look at number 11. Number 11, a baseball player runs forward at 15 feet per second and throws a baseball at a velocity of 80 feet per second at an angle of 120. Okay, so let's draw our horizontal, or our vertical and our horizontal. So first of all, he's running at 15 feet per second. So he's going like this. That's our first vector right there. So, and its velocity or speed is 15 feet per second. And then we've got a baseball that is being thrown at an angle of 20. So this is 20 degrees. And it is at 80 feet per second. So then it says, what is the resultant speed and direction of the throw? So we got to find each one of these. So the first one, B1, the running, is going to be 15. And then what's our angle? Our angle is 0. So it's going to be cosine 0, 15 sine 0. And our second one is 80 cosine 20 and 80 sine 20. Okay, then we're going to put them together. And if you do all of that, you will get 90.18 and 27.36. And it asks you for the magnitude and the direction. So our magnitude comes out to 94.24 feet per second. And our angle is this. And what quadrant is this in? It's in quadrant 1. So we can just use the angle that the calculator gives you, and it gives you 16.88 degrees. And it says, what is the speed and direction of the throw didn't really tell you how they wanted the angle, so I guess we're just assuming it is with the horizontal because that's how the other angles were measured. So there's our direction, and here's our speed of that one. All right, let's look at number 12. A boat heads directly across a river with a velocity of 28 miles per hour. If the river is flowing at 12 miles per hour, find the magnitude and direction with respect to the shore of the boat's resultant velocity. Oh, that's hard. Okay, let's see. So here's our vertical and horizontal. A boat heads directly across a river. So we're going to say it is going here at 28 miles per hour. And if the river is flowing, so we're assuming that the river, the way I have it drawn here, the river is flowing like this. Okay, and the boat went directly across it. So that means the river is flowing at 12, so we're going to go this way for the river at 12 miles per hour. So let's see what this gives us. So for the first one, for the boat, we get 28 cosine of 90, 28 sine of 90. And for the river, we get 12 cosine of 0 and 12 sine of 0. And if you put those together, you should get 12 and 28. Because cosine of 90 is 0. This turns into 0. Sine of 90 is 1, so that turns into 28. This one, cosine of 0 is 1, so that's a 12, and this turns into sine of 0 is 0, so that turns into 0. So we end up with 1228. And when we put that together, to find the magnitude, so it's going to be this, you're going to get 30.46 miles per hour. And our direction, and the magnitude and direction, yes, is this, and this is in quadrant 1, so we can just find the angle. Our angle is 66.8 degrees. So let's find the magnitude and direction with respect to the shore. So this is the shore, and that is our direction, and here is our velocity for number 12. Okay, like I said, drawing the pictures is sometimes the hardest. If you can get the picture drawn, then you can do the problem. So I will give you hints and help you with the picture. Okay, a drone is flying at a speed of 40 miles per hour in the direction of south 70 west. So let's draw that first. Here's this. Our drone is flying at a speed of 40 miles per hour of south 70 west. So that's going to be here, and this right here is 70 degrees, this angle, and it is 40 miles per hour. All right, that's the drone. And then there's a wind of 15 miles per hour in the direction of south 10 east. So that's going to be here, and this is going to be 10, and that is 15 miles per hour. So let's see how we can do this. For our first one, okay, it's going to be 40, and what's our angle going to be? Our angle is going to be from here all the way over to here. So that's going to be since this is 70, this over here has to be 20 plus 180. So that's going to be 200. So our angle is going to be 200 for the drone. And for the wind, it's 15. And our angle goes from here all the way to there. So that's going to be 270 plus 10, that gives us 280. So we got cosine of 280, 15 sine of 280. Now we're going to put them together. And we get negative 34.98, negative 28.45. And when we find the magnitude, that's going to give us 45.09 miles per hour. And when we find our angle, we're going to use this. They're both negative, so the negatives cancel. What quadrant is this in? This is in quadrant 3. So when we put this into our calculator, we get, inverse tangent of this, and we get, your calculator gives you 39.12. But that is not in quadrant 3, so we're going to have to add 180, and we get 219.12 degrees. It asks us for the magnitude and the direction as a quadrant bearing. All right, so this is just our main, this angle right here is our main angle from here to, here's 180, so like maybe here somewhere. It's in this quadrant. And we need to know that in quadrant bearing, so what direction is it? It is south, west, our directions, and then our angle has to go from here to here. So if this big red is 219.12, then we have to find this by subtracting it from 270, and we get 50.88 degrees for our, and that's our angle is as a quadrant bearing. All right, I know this is hard, but just practice and see how it goes. It's good to stretch your mind. All right, let's look at the last part right here, horizontal and vertical components. A vector can be resolved into a horizontal component and a vertical component. The horizontal and vertical are also called rectangular components. Because the rectangular components form a right triangle, you can use trigonometric ratios to find their magnitudes. So let's look at the little picture. Here's your vector. We can have the x and the y. This is the y, this is the x. Here's our vector v right here. This is the horizontal component, and this is the vertical component. Okay, so let's see how we're going to do this. Let's look at number 14. Danica is pulling a sled with a force of 400 newtons using a string. If the string makes a 35-degree angle with the ground, find the magnitudes of the horizontal and vertical components. So we're going to draw a picture. These pictures for these are going to be right triangles. Okay, the string is making a 35-degree angle with the ground. So here's the ground, here's the string. Here's our angle, 35 degrees. It is pulling with a force of 400 newtons. So this is our vector right here. Okay, it says find the magnitudes of the horizontal and vertical components. So we want to find this, and we want to find this. And finding that, we're going to use like SOHCAHTOA. So what are we going to do to find x? What trig function? We've got the hypotenuse, and we're looking for the adjacent. So to find x, we're going to use cosine, because cosine of 35 equals adjacent over hypotenuse. Now, when we do this, I'm actually going to put absolute value around the magnitudes, because the magnitudes are always going to be positive, and depending on what our angle is, it might give you a negative. And so just in the end, make sure that since they're magnitudes, they're always positive. This would give you a positive because the angle is acute, so it would be okay. But here's what we're going to use. This is SOHCAHTOA. Cosine equals adjacent over hypotenuse. So we're gonna solve this and say the absolute value of x equals 400 times cosine 35. And you're just going to put that in your calculator, and you're going to get x equals 327.66. Okay, then to find y, we're going to use sine, and we're going to say sine of 35 equals the absolute value of y over 400, because sine is opposite over hypotenuse. And we're going to solve this, and we get the absolute value of y equals 229.43. So it asks you find the magnitudes of the horizontal and vertical components. You can say horizontal equals 327.66 pounds, and vertical equals 229.43 pounds. And that's what we're looking for here. So let's look at number 15. Okay, remember I said these are going to be right triangles. Ken's running 6 miles per hour in the direction of south 70 west. Find the magnitudes of the horizontal and vertical components. So first of all, let's draw our vertical and horizontal, and let's see how he's south 70 west. So that's going to be here, and this is going to be 70. So we want to draw our horizontal and our vertical. So that means this angle is going to be 20. So this is our x and this is our y. And to find this, we're going to say cosine of 20 equals the absolute value of x over 6, because that's how fast he's going. So the absolute value of x equals 6 cosine 20, and the absolute value of x equals 5.64, and sine of 20 equals the absolute value of y over 6, and so the absolute value of y equals 6 sine 20, and this equals 2.05. So the horizontal is 5.64 miles per hour, and the vertical is 2.05 miles per hour. Now, if you would have drawn this, let's see, when you drew this right here, if you would have drawn this triangle, and this would have been your y, and this would have been your x, and you would have used 70, you would have had cosine of 70 equals the absolute value of y over 6. And I'm pretty sure that gives you the same thing. Let me check. Cosine of 70 times 6. Yeah, so you would get the absolute value of y equals 6 cosine 70, which equals 2.05. And you would have used sine of 70 equals the absolute value of x over 6. And you would have gotten the same thing that you got up there, which is 5.64. So it doesn't matter. Usually we use this angle, but it doesn't really matter, however you do it. All right. So that is the end of part 2 of the applications of vectors. So I'll have some homework for you to try and see how it goes.